Hi, Science in Pajamas. Today we've taken a field trip, as you can see, to my kitchen. Now, the reason why we're here is because we're going to be talking about physical and chemical properties and reactions, mostly focusing on the reaction part. Now, start with this. What is this? Well, it's a piece of paper. As a particular set of properties, a certain density, certain chemical makeup. It's white, it's smooth. So there's lots of different things. It's a solid. We can talk about this, the size of it. But even if I do this, what is it? It's still a piece of paper. Now it's just been ripped in two. Even though the mass of this piece of paper has changed, so is the volume, so the density will remain the same. Same with this. It's going to have the same density that it had before. Different mass, but also different volume, so same density. This is an example of physical properties and physical changes. So a physical change is when you change a substance, or you do something to the substance, but you don't actually change what it is. You can change its size, its shape, you can change its mass or its volume, but there are still basic properties that will always remain the same. I have not changed its density. I have not changed its chemical formula. So I have let this go through physical reactions or physical changes. Because no matter how many times I rip this up, it is still just paper. It's just smaller and smaller and smaller pieces of paper. That's all. So a physical change is when you can change some of the properties, but you don't actually change what the substance is. This is still paper. Now, a chemical change is when you do change a substance into something completely new, and you're going to change its chemical properties. So this, as paper, has a certain chemical makeup. If I was to let this undergo a chemical change, a chemical reaction, I would end up with substances that have different chemical formulas. Now, all the same elements will still be there, but they'll be bonded differently to make a whole new substance. You can also talk about the chemical properties, as in one being flammability. Paper is flammable. What that means is, in the presence of excess heat, like fire, it will undergo a combustion reaction, which is pretty much what we mean when we say it's flammable. It will burn up and it will turn into a new substance. So I feel like burning my finger, so I'm going to put it in there. Let you watch it burn. See? Still some paper left. Try not to burn my hands on the glass. All right. Now, it might have been a little hard to see. There was smoke coming up, and that smoke contains like carbon dioxide, other types of gases. Plus, we now have ash. So that's a lot of carbon right there as well. So all of the elements remain present in one form or another, either as ash or as the smoke. But the smoke and the ash are not the same thing that we start with. We started out with paper and we got smoke and ash. So we actually turned the paper into something that is chemically new. It has a new chemical formula with new physical and chemical properties. God, I love that smell. Sorry. All right. Let's do another one. It's a very common one to do with kids. I oftentimes will do this one in my classroom. We're going to start off with some baking soda. It is a white powder. Put it in there. Okay. And then I'm going to try and get this right. I normally do this with a balloon. We do not have any balloons here, so I'm just going to do our best. I'm going to try and put this on super duper quickly. All right. Yeah. Well, it fizzed a bit, as you can see. I'll clean that up in a little bit. But not just that. Most of the white powder is gone. And look here. There's a gas trapped in here. Now, that's not the air from before. I mean, there might be some in there, but a lot of this gas is new from after I put it on. And what that is carbon dioxide. So what happens is you take a white powder, like baking soda, and you add this clear liquid, vinegar, and it goes through a chemical reaction. That's the bubbling that you see. The powder and the liquid were actually reacting to make something new. The carbon dioxide gas was one of them. So from a liquid and a solid, we ended up making a gas. There is also some new stuff in there. I believe one of the products is water. I could be wrong on that. But there's other stuff as well. So it's a chemical reaction. We are making something new. All right, the last one, which is my favorite, because it's oh so yummy. Going back to fire because, you know, who doesn't love fire? Marshmallow. Give it a moment. Start to see some changes. Starting to burn. Getting bubbly. Lighting it on fire. Yes, I'm doing that purposely. Come on, rest of it. So now we have a marshmallow on fire. We can see that it is causing a change to it. So this outside is very different than the marshmallow we saw before. It's thin, it's flaky, kind of charcoaly. Underneath we still have some marshmallow. But what we did was a chemical reaction. We actually burnt it into this crunchy bit and the smoke that was coming off, just like with the paper. Now the inside hadn't burned yet, but it did start melting. So the inside went through a physical change. It went from a solid marshmallow to a liquid marshmallow. The outside, though, the outside went through a chemical change. It went from marshmallow to ash. So the big difference, once again, between a physical and a chemical changes, did the actual chemical makeup change? Even when you go from water to ice, when you freeze it, it goes from a liquid to a solid, but still just H2O. So that's a physical change. When the marshmallow got hot and the middle started to melt, it's still marshmallow. It's a physical change. But when you change the actual chemical structure, the chemical formula, ash does not have the same chemical structure, the chemical formula as a marshmallow. Neither does the smoke that came off. We made something new. That is a chemical change. So physical change, you change maybe a little bit of how something looks, but you don't change fundamentally what it is. And then a chemical changes, well, you do change what it is, what it fundamentally is on a chemical molecular level. So I hope that was informative. I hope you liked it. I know I liked it because I love marshmallows. Might have to do this experiment a few more times. Anyways, you guys stay awesome, stay amazing, stay cool, and until next time, bye bye.